Good morning, students. Today I am going to explain about the domain decomposition. The domain decomposition, okay, which is comes under the like different techniques for the parallel computations with the threads. Okay, first of all, why we require the domain decompositions? Okay, the what is that? The domain decompositions, okay, which is nothing but okay, it is a process of identifying the patterns of functionally repetitive, okay, means it is going to what is that, solve the all the mathematical functions. Suppose like in the mathematical functions, okay, we are going to use for the different equations, or it may be what is a different solutions or mathematical solutions, okay, with the help of we are going to solve the problems, okay, such that in the cloud computing, okay, we are going to use the domain decomposition, okay, which is nothing but in the given program, okay, we are going to use some of the what is that, mathematical trigonometry functions, that is what is that, cos theta, cosine theta, okay, like that all the equations of that particular trigonometric functions that we are going to written as one of the program, okay, means all the mathematical functions, okay, we are going to bring into the programming level. Like such complexity, such complexity of that particular what is that applications, we are going to use for the decomposition method. I am going to tell for standard equations, okay, what is the decompositions, okay, which is nothing but it is the process, okay, which is going to identifying the patterns of the functionally repetitive, okay, means it is going to like whatever the functions, okay, it is having the everything the function, okay, it is keep on repeating in the independent computations of the data, means like all the functions they are going to execute at the independent platform, okay. Then like whenever we are going to do for this type of iterations or computations, okay, during that time it is going to improve the system performance as well as the programming performance. For this type of what is that computations, we are going to use for the two method, that is empirically what is the computations method, okay, and then inherently sequential parallelism method. I am repeating the two method, okay, which we are going to use for the domain decompositions. One is empirically parallel computations method, and then second one is inherently sequential domain decompositions technique. In the empirically, okay, parallel computing system, you look at this diagram. 1 minute, I'll show the diagram. See, in the in this empirically parallel computing, okay, diagram, it's having the unit works, and they are like below one the they have going to divide the data, okay. First of all, what it will tells for the empirically parallel technique means, okay, whatever the given data or whatever the given program, they are going to divide into number of blocks, okay. See, can you look at this diagram, okay, you will come to know this, okay. Whatever the given the complete data or a complete program, they are going to divide the like number of blocks, or it may be divide the number of segments, or it may be units. So this is about the empirically parallel technique. Here what is that, the process, okay. See, this is the process, okay. The process actually it is going to interrelated to the unit of works. The unit of works, okay, it is going to works on one of the master, like this technique basically it is going to works on the master slave technique, okay, or it may be a master slave model. Like it is going to like what is that, executed for common operations, that is like what is the operations means, okay, they are going to for executed the code segment operations, or it may be decompositions for what is that, for executing the logical operations, and like it is going to perform the what is that, like many computational computational operations with n number of iterations, okay. So this is about the empirically parallel technique. When we come to the inheritance sequential method, okay, here there is no any what is that, segmentations of that particular program, okay. What it will tells means, suppose has a user or has a processor, okay, it is going to send the number of data into that particular unit or that particular server, okay. It is going to execute it one by one, okay, means it is going to executed n number of iterations, means the one program, okay, it is going to executed one iterations, then second program will be second iteration, third program will be third iteration. like the iterations wise means like they are going to executed what is that the count wise, the iterations which is nothing but okay they are going to executing all the programs with the count wise. So after that that whatever the result okay we are getting that it is going to stored on the result device. Okay, so this is about the inherently sequential decompositions technique. Then I'll move on to the functional decompositions. Okay, then what are the functional first of all the like technique for parallel computations okay we are going to use for the two methods, that is domain decomposition and functional decomposition. In the domain decompositions okay again we are going to looking at two method for what is that computing the particular applications or program, that is embarrassingly parallel technique as well as the inherently sequential technique. And then this one is the functional decomposition method like to what is that to computing the thread programs. The functional decomposition so which is nothing but okay it is a process of what is that, yes it is a process of identifying the functional with the different independent computations, which is nothing but you look at this diagram here in diagram okay what it will tells means the process okay it's having the n number of functions okay, that functions in the okay in the unit of work means like in the server it is going to executed independent means like what is that the process is having the group of programs or group of applications okay, that applications it is going to send to the unit of work okay, the unit of work which is nothing but it should be one of the inside the CPU okay. Once it is going to send that group of applications okay into the that CPU, after that that group of applications or program they are going to executed individually means they have taken the each application, the group of application they are going to segregate it into individual applications or individual task, so such that they are going to executed each task in the independent platform or for independent computations. Okay, then after each task or each program of result they are going to store on the result device. See, this is about the functional decompositions. Okay, so then like I will move on to the multi-threading with Aneka. Okay, the multi-threading with Aneka which is nothing but okay it is one of the what is that middleware software to for managing the different clouds, or it may be clusters, grids okay. Why like it is going to managing the cluster and like grids as well as the clouds and data centers means like everything it's having the multiple data or huge data okay, and it is also used for the third party because like in first module I told what is the third party okay and what is the private cloud and what is public cloud everything. So because of that only like we are going to use for the clusters okay what is that grids okay everything means it is going to manages the huge number of data. Then like these clouds are okay going to provide the developers with the advanced okay for capabilities for implementing the distributed applications. Then what is the multi-threading with Aneka okay, what are the technique okay or what are the models okay it is going to introducing means the first one is thread programming model and task programming model. Okay, in the thread programming model okay like we are going to look at the different programming what is the models or thread programming models, that is applications programming model as well as the threads and thread managers. Okay, see like in the application programming model, see like in the application programming model okay, here we are going to use for the different types of what is that applications means okay, here we are going to use for the Aneka entity and Aneka applications okay. Then like how the entity will be executed inside the thread, and then as well as okay the what is that the thread manager okay it is going to handles the internal component okay, that they are going to executed at the distributed threads okay. The distributed threads okay it is going to provide the different task of the Aneka to implementing the Aneka thread manager. So this is about the what is that applications of the thread manager. So we will see, like we will look on the what is the difference between the Aneka thread as well as the